to multiply two different numbers that have exponents on them, well, how does that work? Okay, so that's what we're looking at. So I have 2 squared times 2 cubed. Well, that's 2 squared is just 2 times 2, and 2 cubed is just 2 times 2 times 2. So if I multiply all those together, well, how many 2's are there? There's 5. So I get 2 to the 5th. Okay, so I'll do the next one with you as well. 3 to the 4th times 3 squared, right? So that's 3 times 3 times 3 times 3 times 3 times 3. Okay, so 4 3's times 2 3's. How many total 3's do I have? 6. There you go. Can you guys finish filling out that section, please? All right, so in number 3, I have 4 squared times 4 to the 5th. So how many total 4's am I going to end up having? 7. And in number 4, I've got 5 squared times 5 to the 4th times 5 cubed. So how many total 5's are there? 9. 10 cubed times 10, just 10. Oh no, it's on my highlighter. Undo, no. Huh? Yes, 10 to the power of 4. So what are we doing? We're adding the exponents together, right? So once you figure out the rule, we don't have to write it out every single time, right? So what's 5 plus 3 plus 2? 10. So this just becomes 10 to the 10th. And what's 2 plus 3? 5. So x to the 5th. What's 4 plus 5 plus this invisible 1? 10. So p to the 10th. Okay, so when we multiply with exponents, we add the exponents. And another way to write that is if we have b to the m times b to the n, it equals b to the m plus n. I just add my exponents together. Did my base change at all? No, the base stays the same. Okay. So in the next section, we're not multiplying, we're raising powers to another power. I have like double exponents, an exponent raised to another exponent. So in this first one, I have 2 cubed squared. So that means 2 cubed times 2 cubed. So it's going to be 2 times 2 times 2 times 2 times 2 times 2. How many total 2's are there? 6. So then over here I write 2 to the 6th. Okay, now in the next one, let's do one more together. 2 squared cubed. So 2 squared times 2 squared times 2 squared. Or 2 times 2 times 2 times 2 times 2 times 2. How many 2's? 6 again. Okay, can you keep going, please? Keep going and see if you can figure out the rule. Once you figure out the rule, you don't have to do this middle part anymore. You could just do the last column once you figure out the rule. But you got, once you figure out the rule, then write it down at the bottom. Yeah, they are, huh? Why are you first class student notice that today? That 3 and 5 are the same problem. Maybe. All right, so number 3, we've got 2 squared to the 4th, right? So that's going to be 2 times 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 2, right? 2 squared 4 times, how many 2's are there total? 8 of them. 2 cubed, cubed, 2 times 2 times 2, 3 times, so 2 times 2 times 2 times 2 times 2 times 2. How many total 2's? Have we figured out the rule so we can stop writing this all out? Because especially down here, it gets really crazy. What do you do? Yeah, we multiply the exponents together. So my base stays the same. What's 2 times 4? Uh-huh. And number 6, my base stays the same. And then what's 5 times 2? And number 7, W is my base. What's 5 times 3? 15. Perfect. Number 8, 15 again. So when we raise a power to a power, we multiply the exponents. Does the base change at all? No, base stays the same. Okay, and if we wanted to write our rule in math terms instead, it would just be b to the m raised to the n equals b to the m times n. I multiply my exponents together. Okay. All right, let's look at the back. We've got one more rule to learn. What rule is on the back? Dividing. Dividing. So we have 2 to the 5th power divided by 2 to the 2nd power. I don't know, you'll have to figure it out yourself. So remember, division is just a fraction. So writing 2 to the 5th divided by 2 squared, you can write that as 2 to the 5th over 2 squared. And then when we expand it, right, my 2 to the 5th becomes 2 times 2 times 2 times 2. And my 2 squared becomes just 2 times 2. And tell me, what does 2 over 2 equal? 1, right? When I have the same thing in my numerator and denominator, they just kind of cancel out to be 1, right? So if I have 2 in my numerator, 2 in my denominator, they cancel each other out. I have 2, 2, they cancel out. So how many 2's are left over? Okay, can you do the rest on your own, please? Okay. So let everybody figure it out for themselves, please. Okay. So when I have 4 to the 6 divided by 4 squared, right? I look to see, oops, this, right? What do I have in the top? What do I have in the bottom? What's left over? 4 to the 4th, right? What's in the top? What's in the bottom? I still have 4 left over. Down here, I've got 3 in the bottom. I can cancel out 3 in the top. 3 squared. So I could keep writing them all out, but that gets kind of annoying. So what's the rule? What's the shortcut? Subtract our exponents, right? My base stays the same. And then I subtract top minus bottom, numerator minus denominator. So what's 7 minus 4? 3, so 10 cubed. Base stays the same. Subtract numerator minus denominator is 2. Base stays the same. Subtract numerator minus denominator is, and then the last one, yeah, m to the 7th. So when we divide with exponents, divide with exponents, we need to subtract the exponents. Okay. So if I have b to the n over b to the m, it becomes b to the n minus m. Base stays the same. All right, last thing you need to do is just rewrite your rules, and you can rewrite them like this, you can rewrite them like this, you can write them any way you want to, as long as it'll help you remember. So rewrite your rule for dividing with exponents, rewrite your rule for a power raised to a power, rewrite your rule for multiplying, and then answer which rule matches yours, which rule matches what you just said. Okay, and that's it. I'm going to come around and grade that last little bit, and then you're done for the day. Yes?